Assalamualaikum students. So before we start our lesson, let us start our lesson with the recitation of Mul Kitab Al-Fatiha, and let us dedicate this recitation to our friends, families, brothers and sisters who have passed away. Al-Fatiha. So finally we have reached the final chapter of Elements of Programming, which is chapter 9, covering the topic I/O streams and data files. So in this chapter, you learn about I/O file stream objects and methods, reading and writing text files, random file access, how to use file streams as function arguments, and finally, some common programming errors. So throughout the semester, we have used the I/O stream class library. So the I/O stream class library accesses files by using what we call streams. In most systems, the bytes transferred on the stream is represented by ASCII characters or binaries. In a high-level language like C++, the mechanism for reading a byte stream from a file or writing a byte stream to a file are usually hidden. So this is an example of how a data transfer mechanism works. So over here on our left hand side, we have our computer program. Next we have our buffer. So buffer is part of physical memory, and usually the physical memory is temporary. And finally on our right we have the disk, which stores files permanently. So data or information transferred from a program to the temporary memory or buffer is handled by our iOS stream library, while the data transferred from buffer to file is handled by what we call a device driver. So these are the components of the I/O stream class library. So for chapter 9, we are going to only focus on F stream or file stream, which consists of if stream or input file stream and off stream, which is the output file stream. So when you're trying to store and retrieve data outside a C++ program, you will require two components. First, a file, and secondly, a file stream object. A file is a collection of data stored together under some common name. Usually it will be on disk, USB or CD or DVD. And C++ programs stored on disk are some examples of files. Now the stored data in program files are actually the codes, which later on become input data to your C++ compiler. However, a C++ program is not considered as a data file. Data file refers to files containing data or information which is used in a C++ program. So this example here is a folder which is containing files in a USB drive, and I have examples here of PowerPoint files, C++ file, and also a data file. So you can see here in student.dat, okay, this is an example of a data file because student.dat stores some data about student. Now, in coming up with name for your external files, you have to think about naming your file with something unique. So through this external name, your operating system will try to identify the file. Now each computer operating system has its own specification for what is the limit of size for the file name length. So this is an example of some operating systems. So for DOS, which is an old operating system, it only supports 8 characters plus an optional period and 3 character extension. While recent operating systems such as Windows 98, 2000, XP and Vista, Windows 7, Windows 8 and Windows 10, all of them supports up until 255 characters. Unix system, the earlier ones, supports until 14 characters only, while the current version support up until 255 characters. So because of this support of long characters, you can actually have a file name which is named as this file belongs to Ahmad Idham bin Ahmad Rizwan bin Muhammad Ayub bin Muhammad .c++. So this is allowed because it is within the 255 characters. Now when naming your files, remember that you have to think of file names which are descriptive of or meaningful. Some examples are employee, student, and stock. So this file name represents the data stored in each of the file. We also would like to avoid long file names such as elements of programming. So longer file names require more time to type and may result in typing errors. So the manageable length for file name is usually between 12 to 14 characters, up to a maximum of 25 characters. When you choose your file names, choose names that indicate the type of data in the file and the application used. Most frequently, the first 8 characters will describe the data, and the extension will describe the application type. For example, if I have a file named car rental, so we can assume that this is storing some information about car rental, and if my extension is .cpp, so this is referring to the C++ application. Or, if I have a file called carinfo.txt, so I can assume that this file contains some information about cars, and it is stored in an application that store text files. So the following are some valid computer data file names: prices.dat, brackets, info.txt, exper1.dat, scores.dat, and then math.mem. So .dat refers to data files, .txt refers to text files, and .mem refers to Windows Microsoft Visual Fox Pro file. So these are some examples of extensions for file application. There are two types of files in C++. The first one is text or character based. So this type of file stores each character using individual character code, which is typically ASCII or Unicode. One advantage is that it allows files to be displayed by a word processing program or a text editor such as Notepad. So this is an example of a text or character based file. The other type of file is what we call the binary base. So this type of file stores numbers in the form of binaries and also strings in the form of ASCII or Unicode. One advantage is that it is compact because binary numbers requires less number of bytes, and this is an example of how a binary based file looks like. In order for you to access a data file in C++, you need a file stream. So what is a file stream? So file stream is a one-way transmission path used to connect a file to your program. So the mode of the file stream later on will determine whether the path will move data from file into a program or otherwise. So there are two types of file stream. The first one is the input file stream, which is used to transfer data from a file to a program. And the other one is the output file stream, which sends data from a program to a file. Now, the direction or mode of the file stream is defined based on the program and not the file itself. So we can say that data that goes into program are considered as input data, and data sent out from program considered as output data. So this diagram here shows an example of data flow using I/O file streams. So let's say on your left here you have your program, which is testfile.cpp, and you want to print out some data and store it into a file called student.dat. So then you will be needing the output file stream. Otherwise, if you are reading some information or data from your disk and you are trying to display that through your C++ program, probably on the screen, then you will be needing the input file stream. So, When you read data from a file and use the data in C++, use the input file stream. And when you read data from C++ and store data in a file, you use the output file stream. Different file stream object requires different creation of the file use. So, if you have a program that needs to read and write to a file, both the input and output file stream object are needed. So then, the input file stream objects has to be declared as type if stream or input file stream, and the output file streams are declared to be of type of stream or the output file stream. Now, each file stream object has access to several methods. Some of the methods are first, opening file. So this open file method will connect your stream object name to the external file name. Second, you would like to access a method that determines whether your connection to the file is successful. Third, you also want to access a method called close to close the connection between your file and your program. Next, you might want to use the get method to get the next data item into a program from your input stream. Also, you may want to put your data item from a program onto output stream. And finally, you can also use a method to detect when an end of file has been reached. So let's first discuss about the open method. Now the open method is accessed by calling the open followed by the brackets or parentheses. So this establishes physical connecting link between your program and your file. And this function is transparent or hidden from the programmer. So this connects file's external computer name to stream object, which is used internally by your program. And it is provided by the if and off stream classes. So any open file for input is said to be in the read mode. So this is how you access the open method, and this is how you define the stream object. So this is just like a variable name in file, dot operator followed by the method open, and then you pass as argument the name of the file. So this method will connect external text file name prices.dat to internal program, which is the stream object, which is named in file. And then later on, all the data will save under the external file name called prices.dat. So calling the open method, we'll use the standard object notation object name.open. So again, in this case, my object name is infile. So when you no longer need a file, you would like to call the close method. So the close method breaks connection between the file's external name and the file stream object. So this is always a good programming practice, which is to close your files when you no longer need it. So the example is that, okay, again, we use the stream object in file, followed by dot, followed by the method close, and this will close or break the connection between your file and the program. Note that the close method does not take any argument. So the table here shows some of the file status methods that you can use to detect the status of a file. The first one is the fail method. So this will return a boolean true if the file hasn't been opened successfully and false otherwise. EOF or end of file will return a boolean true if a read has been attempted past the end of file and returns a boolean false otherwise. Next is the good method. So this method returns a boolean true while the file is available for use, and otherwise it will return a boolean false. And finally, the bad method returns a boolean true if a read has been attempted past the end of file, otherwise it returns a false. So that's the end of chapter 9 part 1. We'll continue with chapter 9 part 2. While waiting for part 2, let's take a break and enjoy a cup of tea with some cookies.